Hello everybody, this is Unit 4, Day 7. Alright, so if you're watching this, you either needed further reference or perhaps you were quarantined or stuck at home. Okay, so without further ado, let's get started here. Okay, so before we left on break, we were doing operations with radicals, and the operations were addition and subtraction. And so today, as you can see, I know you all can read, we're going to be multiplying and dividing these guys, okay? So it's really important that we follow this step first. We want to multiply or divide first and then simplify, okay? And so you'll see what I mean. Not saying that it would get you to the wrong answer, it's an easier way. You want to multiply or divide first and then simplify, especially number one, right? Because we can't really simplify anything else inside those parentheses, right? And so what we're going to have to do is we're going to invoke a couple of things, okay? The first one is called the product property, okay? Which allows us to take something underneath the radical, a couple different things underneath the radical, and we can separate them still underneath the radical, but using multiplication, okay? So this is the product property. The other property is the quotient. Whoops. Why am I drawing a blank here? Jeepers. Quotient property. Okay, there we go. I can spell. All right, so the quotient property, very similar to the product, except it deals with division. Okay, so when you got two different things under the radical like so, we can separate it so it's the square root of x divided by the square root of y. Okay, and so that is the quotient property. Okay, and so we're going to utilize both of those properties in order to solve these problems. Okay, so let's zoom in and take a look at number one. All right, number one, okay, we're multiplying these two guys right here, right? And so what you got to do is first, anything that's outside of the radical gets multiplied, right? So stuff outside the radicals always get multiplied with each other. So 2x times 5 will give me a 10x. And then using the product property, I put both of these guys underneath the same radical. Okay, so I'm kind of using the commutative law here, right? I'm kind of putting these guys next to each other and then putting these guys next to each other, right? And so I'm kind of skipping ahead here in a little bit, but hopefully that doesn't confuse you what I just did there, okay? And now we're ready to multiply. So this is going to be 10x, and this is going to be the square root of 18x squared. Okay, and so now we just simplify as is, right? So square root of 18, okay, if you did the hockey stick method, 2 times 9, 2 times 3, okay, pull out a pair of 3s, 3 square root 2, okay? Also, when you take the square root of x squared, right, well, how many pairs of x's do I have? 1. So you bring an x out and none remaining. So what this guy simplifies to be then is going to be 10x and 3x square root 2. And then finally, we can multiply those two pieces on the outside, which will give us a 30x squared square root 2. Okay, that's number one. Number two, as you can see, it's all letters, right? Okay, no big deal. We'll just follow the same process. So nothing on the outside here to multiply with this a squared. So a squared just gets left by itself. And then everybody else gets put underneath the radical. Okay. Multiply those together underneath the radical, right? So we're going to get a cubed b to the fourth. Fix that guy right there. There we go. Okay, and so now we just have to simplify this guy right here, right? So how do we do that? All right, well, we're taking the square root again, so how many a's do we have under there, and how many b's do we have under there, right? So I have one pair of a's, so I bring one out, and then one gets left behind. And then the b's, I see two pairs, so I bring two b's out, and no b left behind. Okay, so finally I can multiply what's on the outside of that radical again, right? So it's going to be a cubed, b squared, square root of a. Let's take a look at number 3. Number 3, all right, I'm first going to rewrite this guy right here. Okay, so this guy can be rewritten as a to the 3 over 2 power. Remember, we don't see it, but that index there is 2 times b to the negative 2 power. And then all of that squared. Okay, now a and b are definitely not the same letter. Okay, so we don't have the same base and we don't have the same exponent. So really all we can do here is just multiply this 2 inside. And so by doing so, I get a to the 6/2 power times b to the negative 4 power. And this simplifies to a to the 3rd, b to the negative 4, and because we don't like negative exponents, that means that b to the 4th goes down below. Let's take a look at number 4. Okay, number 4, we're going to use the quotient property. Okay, and so what we're going to do is we're just going to group these guys underneath the radical. So 2u v squared over 18u v to the 4th. Okay, so this is what it means by to multiply or divide first and then simplify. Okay, because we could simplify this a little bit if we wanted to, but then we'd have to simplify it again anyway once we did the division. All right, so what you want to do then is what we have set up here. So we're going to simplify this fraction here. All right, so it's going to be 5 times, and underneath the radical, this becomes a 1, this becomes a 9. That cancels, this becomes u squared, and then this cancels, this becomes v to the 2nd. So we're going to be left with u squared all over 9v squared. Okay, and that's just by simplifying, or dividing that fraction underneath the radical. And now we're ready to take the square root of each of these. All right, so the square root of u squared is just going to be u. And the square root of 9v squared will give me 3v. And I multiplied the 5 with the u, because don't forget, we got to make sure that guy gets included. So once you take the square root of all that, you're going to have to multiply that 5 with whatever you have left. Okay, so let's take a look at number 5. Okay, number 5, again, we're going to separate that 3. Whoops. Suppose I'll put an equal sign here. There we go. Separate that 3 and put everybody underneath the same radical. Okay, and now we're just going to simplify this fraction in there. All right, so it's going to be 3. Well, expression, right? But it's written as a fraction. So this is going to be a 1. That'll be a 25. That becomes a x squared. That becomes a y to the 4th. Okay, so, and then looks like everything in the bottom cancels, so all I have left is 25 x squared y to the 4th. Okay, and what's nice about this problem is I see nothing but even exponents, and we have an even index, so I know we're not going to have anything left underneath the radical. All right, so it's going to be 3 times, right, well, the square root of 25 is 5. Square root of x squared will give me an x. And the square root of y to the 4th, right, we're looking for pairs of 4, which means I'm going to bring out 2, and none gets left behind. And again, the x, right, we only had one pair, so I bring out 1x. So finally we got everything outside here, so 15x y squared. All right, so finally, now in my mind, all right, I don't, I'm kind of showing you the mathematics of what's going on behind the scenes, but if you're like me and don't like writing a whole lot of stuff, here's what I usually do, okay? I take the square root, and I just kind of mark it over both of them, right? Just to remind me, hey, now we're underneath the radical, just using the quotient rule, okay? So now let's simplify this fraction here. Okay, so it's going to be 2 times, right? So this becomes a 1, that becomes a 16. That cancels out, this becomes x squared. This cancels out, that becomes z squared. So what do we have left? Z squared all over 16 x squared, and then times 2 over 1. All right, so now we're just going to take the square root of everything inside there. So the square root of z squared will just give me a z. Square root of 16 is 4, and the square root of x squared is just an x. And when I multiply those together, I get 2z all over 4x. Becomes a 1, this becomes a 2. So my answer is z all over 2x. Okay, and go through these last 6 problems, and we'll call it a DAY. All right, so use the properties to simplify and find A and B. Okay, so we're going to have to use our exponent rules again to find out, well, and answer their question. Now, if you look here, right, a couple of these have kind of forced us to make it 3 raised to some power. Okay, but the rest of these, right, it's just some number raised to some other number. Okay, only D and E are specific on what they want being raised to a certain power. Okay, so that being said, all right, let's work on the other ones first, right? So this guy here, we have the same base, right? Okay, so what do we do with the exponents? We add the exponents when you have the same base, right? We're multiplying, as you can see, same base, add the exponents. All right, so 1/2 plus 1/4, I have to multiply this by 2 over 2. So I get 2/4 plus 1/4 is equal to a 3/4. So our answer is 5 raised to the 3/4 power. Okay, let's take a look at letter B. Letter B, we're dividing. As you can see, we have the same base, okay, which means we keep the base and then we just subtract the exponents. Okay, so obviously we can't leave it like that. So this is going to become 3 over 3 minus 1/3. And so we get 7 to the 2/3 power. Take a look at letter C. Now letter C, we don't have the same base. Now there's a couple ways we could go about this, but I'm going to go the easiest route, right? And so one of our rules, one of our exponent rules, says that when we raise something to the same power, it's almost like it got distributed over across them, right? So xy raised to the second power is the same as x squared y squared, right? So what we're going to do is we're going to use that sort of concept and sort of take back this 1/2, right? So, because 8 and 2 are clearly two different numbers, we're going to go 8 and 2, all raised to the 1/2 power squared. Okay? And so now, all right, 8 times 2, well, that is 16 raised to the 1/2 power. The 2 on the outside. Now again, there's a couple ways you could think about this. Right? Multiply that 2, right? I distribute that 2 inside the parentheses. So I get 16 to the 2 over 2 power, which is just 16 to the first power. So A is 16, B is 1. Okay, let's take a look at letter F, and we'll jump back to those other two. Okay, so letter F, all right, different bases, right, clearly, okay, but being raised to the same power, which means bring that 3 out. All right, 4 times 2 is 8 third raised to the negative 1/3 power. And again, I'm going to kind of, well, not really cheat, but just I notice that this will turn this to 8 raised to the negative 3/3 power, which ultimately is equal to 8 to the negative 1. Okay. And then finally, letter D, going back to these, we're going to use that same sort of concept, and so that we are taking this 12/4 and recognizing that it's both being raised to the 1/3 power. And so I'm using that sort of distribution over division property of our exponents, right? So I kind of just took that 1/3 back. Again, if I just distributed this back through, I would still be right where I was at, so I didn't break any rules. Whoops. Okay. And now we divide, right? What's 12 divided by 4? Well, that's 3 raised to the 1/3, and then again squared. So I take that 2, distribute it through, so we get 3 to the 2/3 power. And lastly, letter E. Okay, this one, right? Because you can't really take the square root of 27, right? I'm just going to distribute this 2 through. So I end up getting 27 to the 2/2 all over 3 squared. And 2/2 is just a 1, so this is 27 to the 1st power divided by 9, which will give me 3 to the 1st power. So B is equal to 1. Okay, so I'll upload an answer sheet for this, right, sometime either today or tomorrow. All right, so make sure that you look at your homework answers, and if you have any questions on these, make sure to bring those to class. Okay, and good luck.